next up, we have, and I have the pleasure of introducing Vishwa Mehta, Developer Relations Engineer at the Graph Foundation. The Graph, of course, needs no introduction. But just to recap, the Graph is an indexing protocol for organizing blockchain data and making it easily accessible via GraphQL. The Graph enables you to build applications that would be difficult to build without it, or perhaps even applications that completely would not be practical without the Graph. So it's a key piece of infrastructure. And so today, in this workshop, you'll learn how to build GraphQL APIs. And I'll go ahead and hand it over to you, Vishwa.
Amazing. Thank you so much. Thank you so much for that great introduction. I think Kevin really set up the background for my session here. It's kind of like a talk, but also a code walkthrough. And I love the explanation that he did very briefly. It made my job easier. So thank you so much for that. And I'm super excited to be presenting this session here today. Just want to make sure that I'm gonna start sharing my slides. Just give me a sec. And yes. Awesome. This looks good. Cool. So, hey everyone, I am super excited to be presenting my session on the Graph and how to basically build decentralized GraphQL APIs with the Graph at Illuminate 2022. So thank you all so much for joining in. And we will be taking an example of how to use the Zora NFT Marketplace protocol to basically build an NFT API. And I will start talking about that just in a bit. But before that, I'm Vish, and I'm a developer relations engineer at the Graph, and my passion is building deeply engaged dev communities, and I invest a lot of my time to help devs become successful with the frameworks and the tools that they're using. So what this means is that I get to focus on whether or not our documentation, the official Graph documentation is is covering all of the things that new devs need to get onboarded. Also brainstorming new education initiatives and efforts, doing hackathons, giving talks and workshops at conferences and hackathons. So this is basically what I do. And yes, let's get started with what the Graph is. So the Graph is a Web3 indexing and querying protocol for blockchain networks like Ethereum and IPFS. And the Graph community also plays a prominent role in supporting dApp developers by making open decentralized data easily accessible with GraphQL. So we like to believe that the Graph is creating this new standard of how data on the blockchain will be indexed or is being indexed by developers as they now use the Graph protocol. But it is not just an indexing protocol or just a simple indexer. It is now a transparent and robust decentralized network of different participants like subgraph developers, indexers, curators, and delegators. And I can talk about that more in a little bit. But we're building this transparent and robust open network of all of these participants who contribute to making the Graph protocol what it is, and to make sure that developers who are building on the Graph can access data, decentralized data on the blockchain easily. And as an analogy on what the Graph protocol actually is and what it stands for, it does for open data on the blockchain what Google does for the web. So if you know, Google does indexing for all of the data that is on the web that you see, and makes sure that once you search for a particular keyword, it turns up all of these results. And it does that by using its indexing servers, right? And Graph is aiming to do something similar, but in a different and more sustainable way, in a more decentralized way. Using the Graph, anyone can build and publish open APIs, open GraphQL APIs, known as subgraphs, that make data on the blockchain accessible. So I love this diagram. It pretty much explains anyone what, where the Graph comes and fits in without having to say a lot about, without having to talk a lot about it. So let's get started with the diagram itself. If you can see, there's the UI layer, there's the subgraph, or in the indexing layer where the Graph comes in, and there is the contracts which is your application data or your protocol data, which is coming from your smart contracts that you're using that are written on the blockchain. So with subgraphs as the main API layer that sits between the UI and the data layer, which is basically all of your decentralized data from smart contracts, the graph is now quickly becoming a de facto standard of indexing data on the blockchain. And with that, subgraphs is now they're now becoming a new Web3 standard. But that's a lot of like big words and a lot of talk. Let's go deeper into the technology and why we started working on something so passionately that we're working on right now. And we often get the question where the graph came into picture initially, well, the graph is the easiest way to query open decentralized data. And the reason why I say this is let me paint a picture for you. We live in this really data driven world, and all of our data is being stored in distributed like huge storage networks. If you see the blockchain, which is like a distributed peer-to-peer ledger, it is a network, right? And it gets a large number of transactions per day, per hour, per minute, per second. So if just imagine that you're building an application, a really meaningful application that you want to create value with, right? And all of your application data you're getting from the blockchain. Imagine having to index all of that heterogeneous data that is stored on the blockchain. There could be DeFi data, gaming, NFT, metaverse, anything could be stored on it, right? And you want something very specific. So this is where the graph would come in, because it is becoming increasingly difficult to index and query blockchain data. And the reason why we're indexing it in the first place is that for developers to be able to give a very robust, a very performant and intuitive UI UX to their users, they need highly indexed, highly organized data from the blockchain. And so developers have been building, as a solution, they've been building proprietary indexing servers, right? And it is becoming, with all of that data that you can imagine, Ethereum alone gets so much of data. I think a couple million blocks, if I'm not wrong. And then in each block, there's like thousands and thousands of transactions happening with each passing hour. So it's becoming increasingly difficult to index and query all of that blockchain data. And so even developers who have been building and running their own servers, it has been a cost that they cannot maintain. And it's not just about the cost. And let me talk about that now. The problem with the proprietary indexing servers, even if you decide to run and maintain one, is that first, it is a single point of failure. So if your server goes down, your application data, the source of it, is down, right? There's no indexing happening, and so your application is down, and it's not getting any data served to it on the front end. The second is that it is centralized, right? It's a single point of failure, which then implies that it is a centralized server run by one single person, entity, team, organization, etc. Right? And that goes kind of like defies the whole idea and the ethos of decentralization and Web3. And the last and the most important probably is that there is a lot of infrastructure to manage. There are costs involved, like engineering and hardware resources, like a lot of time, effort, and money that goes into it, into running and maintaining it. And even after all of that effort, the code that we need to write as developers to run an indexing server is highly susceptible to errors. So we want something that is robust. We want something that is intuitive, that we can take care of once we've built it, right? And that's where the graph comes into picture. It is a global open API, a global and open GraphQL API, which is also not just an API, it's a transparent and open network of various participants. There is the subgraph developer, who builds the subgraphs, which are the open APIs that query all of the indexed data to the front end. Then there are the indexers basically run their own graph node, so that subgraphs developers can be served index data that their indexer indexes from the blockchain. And then there are curators who signal. That's another very important participant, a very important role in the graph decentralized network, which is not as technical, but they do all of the due diligence on the subgraphs that are deployed on the network, and they start signaling on it using GRT, which is the network token, the graph token, and they start signaling on all of the high quality subgraphs, just so that the indexers can prioritize which one is more good quality and which one to index first, so that the subgraph developers, once they've deployed their APIs, they can start querying data to their front end. And then finally, there is the delegators who delegate their GRT, the token, to other roles in the network so that they can use it to stake and participate in the network. So as I briefly explained here, that is basically the graph decentralized network, right? And why the graph is now creating this solution using the decentralized network is because we no longer need a centralized indexing server. We can now rely on something that is taking the decentralized route, so that we can make sure that there is a better approach to indexing data, more efficient approach to indexing data from the blockchain. And that's why we say that that the graph is the easiest way to index and query blockchain data efficiently. And it is also transparent and open, and built on top of GraphQL. So GraphQL is another key feature, key piece in the whole infrastructure that the graph is providing in terms of indexing data for the blockchains. If you know, or if you've ever used GraphQL, you know how great the developer experience with GraphQL is. It's basically like it's basically like REST endpoints, in the sense that it's an HTTP endpoint that you're hitting with the request, and then it gives the response. It is better in the way that it gives you exactly the data that you're asking for. So instead of giving a huge dump of data from the server, just like REST endpoints do, GraphQL endpoint is a single endpoint that you will need to request different kinds of data or a very specific piece of data from your backend, and it will give you exactly that. If you ask for more types of data, it can give you in one single request, as opposed to REST, where for 4 kinds of data, you would be making 4 different requests. So there's a lot of other developer experience benefits like this, like introspection. There's a lot of intuitive documentation that you can start introspecting. There is the query builder and the playground, but that's for another time. If you want to learn more about the graph, feel free to reach out to me and I'd be happy to talk about it. But the graph is built on top of GraphQL to power its global open API, and using which it is powering use cases that include but aren't limited to things like NFT marketplaces. There's galleries and metaverses, music and video platforms, there's social and communication platform, DAOs, governance, so much more. Oh, DeFi. DeFi is another big one that I forgot. And the graph is powering DeFi. All of these cute little icons that you see on the right, these are some of the best projects and best protocols that you may already know of that are being powered by the graph. And DeFi dapps are querying on-chain data, like trade and exchange volumes, total borrowed, supplied, staked, asset prices, wallet balances, and so much more. But not just that. The graph powers complex applications that weren't possible to build before with the same kind of user experience and user interface, the same kind of robustness and performance, or the same kind of efficiency. And now it has been powering websites like CoinGecko and CoinMarketCap. There is NFTs and DAOs like Foundation and Juicebox DAO. Uniswap is one of the first ones that started using in the DeFi space, started using the graph to power their platform, and they also have a subgraph. Synthetics is another one that I love to mention every time. And there are so many more being added to the testimonials. And 350 plus dapps have been migrated. The dapps are dedicated to decentralization, paying for query fees in GRT. So all of these dapps that you see on the screen right now are applications that were built by developers who now use subgraph data that is indexed by the graph network and is powered by the GraphQL API, which we call the subgraph. So all of their data is now being, is now being queried by the subgraphs and indexed by the decentralized network. And for querying data from the subgraph, they are now paying query fees in GRT on the network. Well, the Graph hosted service is currently supporting 39 different chains, and it has been supporting subgraphs and dapp developers for over 4 years now. Now, this is the point where I think it becomes important to make the distinction, because so many times we miss to talk about hosted service and how it is different from the decentralized network, because I fail to realize that there are so many people who do not understand all of these like both of these two different services and why they are different and why one holds specific value over the other. Well, the graph, just to put everything into perspective, the graph started with the hosted service. That was the initial idea that we came up with, the initial service, which was run by our hosted services, the graph's own in-house indexing server that is run by one of our initial core dev teams, EdgeNode, and it is still being run. The primary difference between the decentralized network and the Graph's hosted service is that the hosted service is being run and maintained by the EdgeNode team right now. So you could say that it is being centralized at the moment. And the decentralized network is the network that I spoke about some time ago, which is the network of different participants. So it's not centralized. It is decentralized in the sense that all of the various participants come together to make the whole indexing. They contribute to indexing the blockchain data, and the subgraph developers, all individual developers, come to then contribute to the subgraph development ecosystem by building subgraphs, so on and so forth. And another key difference here is that the graph's hosted service is completely free, and the decentralized network is now being, the way that you would contribute or participate in the network is by using the token. So there is no upfront cost to any of these services, but in the case of the decentralized service, that's one main distinction, is that once you have deployed your subgraph and once you start querying data from that subgraph, you have to pay query fees on your subgraph. And as an indexer, if you're running a graph node, your own indexing server, then you would have to stake a certain amount of GRT to begin running that indexing node. And as a curator, of course, you're staking your GRT to signal on a subgraph, and you're getting that from the delegators. So that's another distinction that should be made between the Graph's hosted service and the decentralized network. Currently on the hosted service, we are live on 39 different chains, which includes Moonbase, Moonriver, Moonbeam. And one of the initial ones that we went live with was Ethereum, obviously, and Near, Polygon, Xstar, BNB, Celo, Avalanche, Arbitrum, and so many others being among the top ones that are being continuously used by subgraph developers to deploy their subgraphs on. Moving on, let's see some code. Now, I would like to start by apologizing that right 2 minutes before this session, my demo actually broke and I've been unable to get it to start working. So as a solution, what I've decided that I would love to do the code walkthrough of which is like the code walkthrough version of my live demo, I will be walking through all of the different steps that come together to then design, deploy, and test out your subgraph APIs, your GraphQL APIs, instead of doing the live demos, unfortunately. But the Moonbeam team was very generous to let me know that there's this Moonbeam community call, or something that happens every month with the community. And I would love to see how I can schedule something to do a live demo there. So if you're seeing this, let's make sure that you tune into that for the live demo. And without further ado, let's jump into the code walkthrough of it so that we can talk about how to actually build a subgraph, how to design it, how to deploy it, and how to test it out. I'm gonna have to start sharing my screen. So let me quickly switch the presentation mode. Awesome, there you go. All right, so for the sake of this session, which was supposed to be a workshop, but for the sake of this example, we're going to be referring this guide, which is amazing. I swear by it every time I do these workshops, because it takes you through what the graph is, what subgraphs are, basically gives you a good brief overview of it, along with the prerequisites, and then explains how to use the Subgraph Studio, which is the you could say development environment, or like kind of like a GUI that you can use to build your subgraphs and deploy them to the decentralized network. So in this example, we will be taking the reference of this guide to understand how to build subgraphs using the Subgraph Studio. If you want to deploy on the hosted service instead, then you would be using something like the hosted service. And I can quickly show you how both of that happens. So the first thing that you do is go to thegraph.com and go to Subgraph Studio in the case that you would like your subgraph to be on the decentralized network. And in the case of deploying it on the hosted service, you would want that to be this option that you click, create and explore subgraphs on the hosted service, right? So I'm gonna.
Hey, we cannot see your screen yet.
Oh, I'm so
We can
sorry
only
about
see
that.
it.
Okay, cool. Let me try. Thank you so much. Let me try sharing that again. Okay, I think this should work.
Okay, now it's showing the Subgraph Studio. Yeah, perfect.
Awesome. Awesome. Thank you so much. All right, so let's quickly backtrack. This is basically the Graph official website. So if you go to the landing page and you go to products, you can navigate to these two options, either of these two, the Subgraph Studio and the hosted service. For the decentralized network, you would want to click on the Subgraph Studio. And for the hosted service, you would then take this route. So for the sake of this example, I'm going to be choosing the Subgraph Studio, and that would take me to my Subgraph dashboard. Now, as you can see, I'm already logged in, signed in using my my wallet address. So you can quickly do that too. These are going to be, this is going to be one of the two main prerequisites for you to be able to start building subgraphs. The first one is that you need a MetaMask wallet. Oops, something wrong with my studio. I'm going to give it a second to load. But yeah, so that's one of the two main prerequisites, that you would need some kind of like a crypto wallet to be able to sign into your Subgraph Studio. And it makes it even more easier if you have a MetaMask wallet, because MetaMask comes with this Chrome extension. So you can just enable the Chrome extension to then be able to sign in. And yeah, so by the time the Subgraph Studio loads, I think there's some issue with my internet, but by the time the Subgraph Studio loads, I think we can get started with the other prerequisite and the guide. So the second one is that you would need Node.js installed on your machine. And the reason why we need that is that we would want to, as a first step, we would want to install npm install the Graph protocol right here, the Graph protocol CLI, which is the Graph CLI. And you can do that using this command. Now, the second step here would be to, there are three main steps to building and deploying a subgraph. The first one is like the step 0 will be installing your Graph CLI, but that is something that you do just once. Once you've done and installed the Graph CLI, it's going to be, it's going to let you use some utility commands, some really nifty commands like graph init for you to be able to initialize your subgraph, and graph auth, graph deploy, and a couple more like that. So the first and the foremost step is making sure that you understand how to deploy this, run this command, which is the graph init command. Now, the easiest version of this would be just graph init and then subgraph studio. All of these other flags here, I'm going to explain what that does. So this is kind of like a long form version of the original, the simplest graph init command. What this one does is that it specifies a couple of flags with some of the values that can then, already initialize your subgraph with all of those values fed into your YAML file, which is kind of like your configuration file that describes your subgraph, the network that it is going to be deployed in, the data source where, like the network and the smart contract of the data source. So in this case, it's going to be, the network is going to be Ethereum mainnet, and the contract name is, the smart contract name for the data source is going to be token, because we're using the Zora NFT marketplace for creating our NFT API. What we're building here basically is an API that can then query data that are that the graph indexes from the Zora NFT smart contract. And the reason why I love this example is that it has an open smart contract address, the media contract, that you can use to sort of use as a building block for your applications. So you could either use it just as a dashboard, analytics or visualization dashboard, where you are querying all of the data from the smart contract by listening to some events like transfer event, in the case of the ownership of the NFTs being transferred, or the content URI updated event in the case of a new contract being minted, new token being minted, or the content URI being changed. So that's basically about the Zora NFT smart contract, and we are using this address. So as you can see, the from contract flag here would then contain the address of your smart contract. This is still loading for some reason. But yeah, so the from contract flag is going to contain the address of your smart contract. The index events flag is basically telling your subgraph. It's describing to your subgraph in the YAML file that you want to be able to index all of the events from the smart contract that are being emitted, right? From through the ABIs. So that is the graph init command. And once you run this, it is going to scaffold the basis, the foundation of your subgraph, right? And it basically creates like this whole folder structure. I wish I could show you, but this whole folder structure of a couple of like different files, like the subgraph YAML file, there's the schema.graphql file, there is the mapping.ts file, and these are the three main files that if you want to define and deploy your subgraph, these are the three main files that you would want to be editing. So let's get into understanding what all of these different files do. Well, I'm going to zoom in a little bit for you guys to follow along. It consists, like the code base consists of some of the most important files, which are the first one is the subgraph.yaml, which is basically the configuration file that I talked about. It contains all of the subgraph manifest information, like the data source, the events that we want our subgraph to listen to when they're being emitted from the smart contract, the token entities, like the entities that we want to be defined in our schema.graphql file. Now, entities are basically any types, data types that you want your subgraph to then be able to query and query to your front end. So for example, from the Zora smart contract, you want to be able to query two main types of data, which is the token data and the user metadata. So you would want to then define two kinds of entities in your YAML file, in your subgraph.graphql file as data types, the entity using the @entity directive. So there would be a type token entity and then a type user entity, which would then have all of the top level fields that you want your subgraph to query and serve to your front end for the user metadata, and similarly for the token data type. So that's about the subgraph.yaml file and the subgraph.graphql file. And lastly, there is an assembly script mappings file, which is the mapping.ts file. And in the mapping.ts file, you would be writing your main business logic, which is all of the functions or the event handlers that you want to be executed when an event is being emitted from the smart contract. Your subgraph listens to it, and then you want your subgraph to run a particular business logic or a particular event handler to map that event to all of the local logic that you've written in your subgraph file. So that's something that you would basically write in the form of assembly script. So if you've written anything like JavaScript or TypeScript, assembly script comes very close to that. And the Graph CLI comes with a TypeScript support out of the box. So it comes with a TypeScript library. And so for that, the second step would then be to define your data and then make sure that you're running a very important command, which is the graph code gen command that I will come back to later. Moving on, the schema.graphql file is where we define our data. So as I've described, there is the type token entity, which has all of the top level fields that we want our subgraph to query and serve to our front end. And then there is the type user entity, which is ID, tokens, and created. And now tokens and created have a relationship, a one-to-many relationship with owner and creator. So for that, we're using the derived from directive. What this means that we could basically create an array for creating that relationship. The reason why we're not using that here is that GraphQL lets us use this directive, the derived from directive, which basically lets us do what an array could do to store all of that data in that relationship, the one-to-many relationship. But this is more performant, right? And so we're creating a relationship between all of the tokens that are being owned by the user owner and all of the tokens that are being created by the user creator. So that's it for all of the data that we're defining as part of the schema.graphql. And for this purpose, I would say that it wasn't in the prerequisite, because you could basically just understand what this particular code does and learn how to write your schema file and write a couple of queries, and you would be good to go. But if you want to get the most out of this experience, the most out of this workshop material, then it would be great if you could at least have some foundation or basic knowledge of GraphQL, how to write queries, what are mutations, what are queries, subscriptions, so that you can understand how the GraphQL API request and response structure works, how to write queries, and what kind of directives or data types we have, and stuff like that. If you'd like to read more about the derived from directive and why exactly and how exactly it's more performant than an array, then here it is described. Once you've written your data file, which is the schema, your schema file, which is the schema.graphql file, you want to run the code, the graph code gen command. Now, what this does is that it gives you, it generates some TypeScript or assembly script types from a combination of the subgraphs, GraphQL schema, and the contract APIs. So if you see the folder structure, the code base of the subgraph, once you initialize the subgraph, it has scaffolded all of these APIs from the smart contract, right? So, and you've written the GraphQL schema. So as a combination of the GraphQL schema and the contract APIs, what the GraphCodeGen does, the command does, is that it pulls together a whole TypeScript library and a bunch of assembly script helper functions and types that you can then import in your mapping.ts file, where you will be writing all of the mappings, right? And this is basically where, so this is the YAML, this is what the YAML file looks like. Just backtracking because here it is described so that you can get a better graphical visualization of it. But in the data sources field, there will be kind, which is the Ethereum or the contract. That's the network mainnet. The name of the the smart contract is token that we're using, and then the source is then the actual address of the smart contract, which is this one. There is the ABI, which is again token, and then the start block. I'd like to highlight this part is because if you start indexing any smart contract, it would then start indexing from, without this defining the start block, it would start indexing from the genesis block. So to save up for all of that syncing time, you would want to use the start block, define the start block. So if you know exactly what block your transactions or your data that you're looking for is, or maybe you just want the latest block, right? And you don't care about all of the other like historical data on the smart contract, then you can search for that particular block. This is the last one. You can search for that particular block on Etherscan and make sure that you define the start block here. And then the mappings here, as part of which there is the entities field where we define token and user. If you remember from the GraphQL schema file, that those are the data types that we want our subgraph to query to the front end. So we're going to be defining that in the first place in the entities, under entities in the YAML file. And lastly, we also define the event handlers in the YAML file, which is basically all of the events that we want to map to the events that are happening on the smart contract, that are being emitted by the smart contract, and that we want to write business logic for, right? All of the data that will be coming in and the data that we want to deal with, we will be defining event handlers for only those. So the purpose of this one, where we have the token URI updated and the transfer event. The token URI updated, just for brief explanation, the token URI updated event is basically an event where the URI or the link to the token on the web is being updated, right? And then there is the transfer function, the transfer event, which which is, there are two scenarios to the transfer one. Either there is a new NFT being minted if it does not exist on the smart contract, or there is an NFT already, which in which case, if this event is being emitted, what it means is that the ownership of the NFT is being transferred from one owner to another, from one user to another. And for that, we want to be able to handle this event so that we can make sure that we're storing the data of the new owner that has now bought that NFT, or in the case that the NFT did not exist, we want to be able to store the data of the new NFT being minted so that we can use it in our application data. So that's it about the YAML file. And the last but not the least is the mapping file. So as you can see here, after running the GraphCodeGen command, I have then I would have then imported those assembly script types and the files that have been generated, which have all of those helper functions from the TypeScript library that I want to then use in my code that I will be using to write the handle transfer event and the handle token URI updated event. So as you can see, I'm importing two pieces here. The first one is the token file from the token folder generated by the command, and then the schema file in the generated folder. So the token file, just to give you some context, some insight into that, the token library is basically all of the helper functions that let you interact with the smart contract itself. So the way you interact with the smart contract is that you cannot write using this to a smart contract. You can only read. So we will be reading data from it, and then as part of the using the schema one, we will be both reading and writing data to and from the graph node.
Vishwa, unfortunately, we're just almost about of time, so maybe just take a minute to wrap up.
Yes, thank you so much. I think I'm close to wrapping up. So this is the mapping file, and I've already explained what each of those events stand for and what each of those handle event, like the event handlers, do and execute. So once you're done with that, the final piece here would be to deploy your subgraph. And using this subgraph studio, we're basically deploying the subgraph to the decentralized network, and you can do that using two commands, which is the graph auth studio command and the graph deploy studio command with the subgraph name that you have. And it should take you to this subgraph dashboard that should be here. And once it is deployed, then it would show that it is completely synced. And you can go to the subgraph playground to run an example query. And once you hit the play button, that would then, in response to your request, that would then give you the response of all of the data that you're asking for from the smart contract through your subgraph. And there are a couple of sample queries here as well, so you can try it out, give it a shot, and please don't hesitate to reach out to me. These are some of the resources that I'd love to send to you. So feel free to ask any questions or reach out to me if you want to know more about subgraphs.
Thank you so much, Vishwa. This is amazing.